Today's topic is using Pythagorean theorem to find A, B, and C. And the essential question we're trying to answer is, how do you use the Pythagorean theorem to find the missing side of a right triangle? If we're looking at a right triangle, then what we have are two legs and the hypotenuse. The hypotenuse is the longest side of the triangle, and the legs are the two shorter sides, and those legs make up that right angle. So the legs are shorter than the hypotenuse, and we like to call those sides A and B. Those legs are A and B. And our hypotenuse, we call it C. The Pythagorean theorem says that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. And that's really wordy, and we'll talk about what that means. We'll look at what that means shortly. But the formula of the Pythagorean theorem is a squared plus b squared equals c squared. So in other words, the square of a plus the square of b is going to equal the square of c. Let's see what that means. Let that focus. Okay, so if we're looking at this triangle here, think back to our starburst activity, where if we make a square out of each side of the triangle, so if this side was 7, and we make a square that is 7 by 7, so this side was 7, this side was 7, altogether inside of this square we would have 49 smaller squares. Because 7 times 7, 7 rows of 7 squares. We would do the same thing with the second side. So if we had 24 squares going across, we would make 24 squares going down. So when that means we have 24 rows of 24 squares. So what we would do is 24 times 24, which is going to give us a total of 576 squares. So in this larger square, we have 576 smaller squares. And so we're going to draw the last square. So we don't know how many squares are inside of here. But the Pythagorean theorem says, let's let that focus. The Pythagorean theorem says that if I add up the total number of squares in the smaller two sides, then I know how many squares are in the larger side. Adding these two gives me the total amount of squares in the larger side. So if I add 576 plus 49, I end up with 625. So in this, I know that I have 625 total squares. 625 squares in the large one. And remember, if I have a total of 625 squares, I don't really want to know how many total squares I have. I want to know how long is this missing side. So if I'm looking for this missing side and I know that this is a square with a total of 625 squares, I can take the square root of that 625, and that will give me the side length that I'm looking for. So the square root of 625 is 25. So that means that this missing side here is 25, and we're dealing with inches in this case. Let's try another one. if I'm looking at this triangle, I have one side length that is 5 centimeters, and I want to turn that into a square. So it's a 5 by 5 square. That's 5 going up, so that means I make a 5 centimeters going across. Then I need to find my other square, or make my other square. So when I make the second square, if it's 12 centimeters going across, then I need to make it 12 centimeters going down. Let's focus this a little better. It's 12 centimeters going across, which means I'm making a square, so it's a 12 by 12 square. So my 5 by 5 square, when I multiply 5 rows of 5, I have 25 squares inside of there. When I multiply my 12 by 12 square, I have 144 squares inside of there. And I need to make an additional square for my larger side, and I know that the smaller two squares added up equal how many squares are in my larger one. So that means I can say 144 plus 25. That gives me 169, which means that I have 169 squares in this larger square here. And remember, I'm not interested in how many squares are in the large square. I want to know how long is this missing side. So if I know that this is a square with 169 total squares, to find the length of one of its sides, I need to take the square root of that number. So square root of 169 is 13. So that means that my missing side is 13, and I was dealing with centimeters, so I will call that 13 centimeters. Now let's take a look at this one. I'm going to do the same thing, more or less, but it's a little bit different. You might have already realized this one's a little bit different than what we've done. So I'm going to make my squares the same way I have been. Now, in this case, I have a 12 by 12 square. So 12 by 12 square, 12 times 12 gives me 144 squares altogether inside. This is a 15 centimeter square, so this is a 15 by 15. And 15 times 15 gives me 225. There are 225 squares inside, small squares inside of this large square. Now this one is what I'm looking for. I don't know how long this side is, but if you notice, this time I don't have my A and B to add up to C. I have C and I have one of my other sides. But remember, my two small squares add up to my large square. So this plus this are going to equal that one. So the small two add up to the large one, and if I know my large one and one of my small ones, I can subtract to find how many squares are in that missing one. So remember, the way I know the difference between my A and B versus C is A and B will make my right angle. So this side is A and B. It doesn't matter which one's A or B. What really is important that we recognize which one is C. C is the one that is not touching my right angle. It's a cross. C is a cross from my right angle. C is across from my right angle. It is not touching my right angle. So C is always my biggest side. So these two squares will add up to the number of squares in C, in my longest side. So remember I said if I know the longest side and another one of the sides, I can subtract to find the missing one. So that's going to be 225 minus, this time, 144. When I do that, I get 81, which means that there are 81 squares in this smaller square here. Well, if there are 81 squares, I need to take the square root of 81 to find how long just this side is, and that's going to give me 9. So that is a 9 centimeter side. Let's try one more like that. In this case, I have a 50-inch side, I have a 14-inch side, and a side that I don't know. Now again, I'm going to make my squares. So this was 50 inches here, and I'm going to make this a 50 by 50 inch square. This is 14 inches here, so I'm going to make this a 14 by 14 inch square. And this one is the side I don't know, but we're going to find out what that missing side is. So, what do I have? What do I know? I know that I've got my 50 inch by 50 inch by 50 inch here. So 50 times 50, so that's 50 rows of 50 squares, which leaves me with 2,500 squares. And then here I have a 14 inch by 14 inch square. So the total number of squares inside of there is 196. Because 14 times 14 gives me 196. And then my last one is what I'm looking for. But I know that this is my longest side. This is my longest side. And I know that the total number of squares in these two smaller ones will add up to this one. I know this is my longest side because it's across. It's across from my right angle. The one that is across from my right angle is my longest side. That is my C. So I know that 2,500 minus 196 is going to tell me how many squares are in this bottom one here. So that is 2,500. Let's get a little more focused. 2,500 minus 196. That's going to leave me with 2,304. So that means that I have 2,304 squares in this bottom one here. If I have 2,304 squares here, then I know that the missing side of my triangle is only one side of that square, which is the square root of 2,304. So I'm going to take the square root of 2,304, and that is going to give me, what is the square root of 2,304? Let me grab my calculator. 2304. Sorry about that, I didn't have that one ready. So my square root of 2,304 is 48. So that means that the missing side that I did not know was 48 inches long.